Hello students. In this video we're going to be talking about scatterplots and the homework you're going to have to deal with. So it would take me forever to draw these graphs by hand, so we're just going to look at a printout here of some of the problems. We're going to start off just making some scatterplots. You'll have some data, you'll have a plot, a nice graph with everything already labeled, and then you just go through, plot those points. Should be very straightforward. Then you're going to get to some questions. Actually, okay, you don't have to do the trend line just yet. Then there will be some points that will already be graphed for you, and you're going to draw the line of best fit, and we'll talk about that here in a few minutes. And then there's some questions where they're going to have the scatter plot and the line of best fit already taken care of, and you'll need to answer questions on those. Just do a little bit of analysis, and then even given the actual equation of that line of best fit. So it doesn't look too terribly difficult. Then we're just going to get down into some of these things. Let's see if we got here. Residuals. What the heck is a residual? I'm not sure about that. Well, we're going to have to figure out what that's all talking about. And then some of these scatter plots and then residual plots. Whoa. And matching the residual plot with the scatter plot and letting us know if it's a perfect model or imperfect or whatever. And alright, so let's start dealing with the theory so we know how to deal with all these problems and scatter plots and collecting data. Okay, so first off, how to plot a scatter plot. Well, if you have the table, then you just plot the x and y axis. So there's a nice scatter plot, and there's a trend line or line of best fit. So how do you draw one? Well, number one, make sure it's straight. Number two, make sure you have about an equal number of data points above and below that line of best fit. Obviously, you may have seen this before. If you have positive slope, then that would mean a positive correlation between your independent and dependent variables. Negative slope would negative correlation. And then whenever you are making predictions, you want to use that line, not the data. The data is exactly that. For instance, if you're just always going to the data, then you may pick one of these other points which is really far outside of what that general trend was. So for instance, if I'm told to make a prediction for this number of days, what was the dollar amount, go up here to the line. Do not say go to, the dot here or the dot right up there. So another thing to remember always, the slope there. Here we've got the change in money or the change in days. So use that line of best fit to make predictions or to make a note about the slope, or maybe we're better off to say the increase or decrease in the change in y per change in x. That's the slope. Okay, so there's our scatter plot. So for instance, this would be maybe $3 for every 2 days, which then that would correspond to $1.5 per day. Okay, so that's some analysis that you'll have to do with the scatter plots. If you want to estimate what this equation is, then obviously find b. That's going to be your y-intercept. And then pick some other nice point and find the slope between b and that other point. And there you go, you've got your y equals mx plus b. Alright, so let's talk about those residual things. Well, a residual is the difference between a recorded value, that's one of those data points, and a predicted value, which means a point on the line of best fit. So it's the formula, if you want it, it's residual equals recorded minus predicted, or data point minus line of best fit point. So here's a terrible scatter plot, but whatever. There's an even worse line of best fit, but okay. So the residual would be this distance right here for this particular x value. So there's obviously lots of, for every data point there would be a residual, the difference between that and the line of best fit. Another residual might be here from, I'm trying to make this vertical here so you can see that would be vertical from, say, this dot right here, which that's not much of a dot. The residual will be here. From this x value right here, that would be the residual. Since it's the recorded minus the predicted, recorded is, and up here the recorded is larger, then at this place right here, the residual will be positive. Down here, the residual would be negative. And because of that, you can actually have a residual plot where you plot now all of those residual values. In this situation right here, this scatter plot, all of those guys up there, those points would have positive residuals, and on a residual plot would correspond to like a bunch of dots right here. And then probably, since we had a few points right here below the line of best fit, then their residuals, when they would be plotted, would be down here. And then in this region, we had a few dots that would correspond to very few up here positive, and then all these dots down here would be right down there. Okay, that's an okay residual plot. It means that, you know, if we look here, we've got about as many above this x-axis as there are below. So that's okay. That's had a pretty good scatter plot. Now, if our residual plot looked like this is awesome. This is great. This means we're really, our trend line or our line of best fit really, you know, lined up well with where all that data was. Now, if we got the data points up here and data points down there, and this is what the residual plot looks like. Oh, this is terrible. Awful. Try again. Draw another line of best fit. Okay, so that's scatter plots, lines of best fits, and residuals. Hope you enjoy working on these problems, and let me know if you have any questions.